So I would say that the SOLAS 3.0 is the main new thing in the science conference.
That's our next science plan,
Yeah.
3.0.
Yeah.
That's right. The third one.
Mhm.
Very creative, I'm sure.
So when this program started, one science plan was written. So next, what we are going to do next 20 years. So that is over now. Now, you know that problem is still there. So we have understood partly. So now we are writing what will be done next 20 years. So this is the meeting where it will be decided what way our SOLAS will be moving, and whole science plan will be written for which international SOLAS people will be following.
Right.
And as far as the next thing too, I mean, scientifically, we're learning that during this meeting. We have invited the very best scientists from around the world to give talks, and they are informing the whole community for the discussion. The way that these science meetings work is very interesting, because we need the discussion, we need the collaboration, and then after that we go away and find out what the new things are. And so our meetings are in the morning. We have talks where everyone listens and learns, and then the afternoon is all discussion groups and poster sessions where everyone talks around their science. And so really half of this meeting is trying to answer the question you just asked. What is the next thing? And we're going to get that from the young people who are here, from people all over the world come here, and they discuss what they view as the next thing. And we are watching and taking notes, and we will meet after this meeting with the scientific steering committee and try to capture what we hear at this meeting. The thing about our science plans, and I helped write the very first one many years ago, is mostly in all science, it's a incremental understanding that and so every question that you ask doesn't exactly get answered before asking new questions. It's this why science is such a fun occupation for me, is that you never know the end. You always learn more, and then you can ask new questions, and you learn more and ask new questions. So I think that all of the items, I think there were 3 scientific foci for the first plan. It ended up 5 for the second plan, which is my point. Is everything you have new questions as you answer the ones, and the ones that are put there to start with, they develop into more research on the same thing, because we now know we need to know more. It's a I'm not explaining it very well, but there's a transition, I think, for everything that SOLAS does. We learn new things, we ask new questions, we learn about those new questions, and we ask new questions. And in doing that, we develop a more comprehensive understanding of the air-sea interface, and the interaction between atmosphere and the ocean is what we're trying to understand. Will it be the same now that it's warmer, or will it change? And those fundamental scientific questions are trying to be asked. So I think that there are phenomena that, like de-oxygenation and things like that are individual things, upwelling systems and fisheries and things like that that are part of the mosaic of what SOLAS is trying to do.
But I think we can give some examples of things.
Okay.
I mean, I think extreme events in the SOLAS domain. This is something that's entering the science plan that wasn't technically in there from the very beginning before. I think these things like deoxygenation, things like the changing carbon sink in the ocean, I think this is also a big topic. I think sea ice and everything that's happening with sea ice and also land ice, I think this is also, like at the coasts, this is also a big topic. And I would say that not from the discovery science perspective, but from this kind of solutions perspective, everything around marine carbon dioxide removal is on the table, because I think there are so many questions regarding marine carbon dioxide removal. So MCDR is what it's called. And it's a huge topic now. Everyone is getting in there. And I think there are some fundamental research questions to ask about that. So I think MCDR is a really big topic.
Just one example I will see. Till now, people are very happy. At least some happiness was there that whatever CO2 we are producing, about 30-40% is going to the ocean. So at least in the atmosphere it is going less. Now when we are studying, now as they have told, because of high temperature we are losing oxygen. Now we lose CO2 also. Whatever has been absorbed till last 30, 40 or 50 years, that will be again going back to the atmosphere. So what will happen to that? So these type of questions, this type of understanding are getting developed. And as they have told, now how to remove the CO2? So there are, now people are talking about removal of CO2. So whether you can do seaweed culture production, or you can do removal by iron fertilization, or direct you can remove CO2 from the atmosphere, directly put in the basalt layer. So there are many ways, but not means we know the how to remove, but what will be the future consequences? Suppose you are removing CO2 and putting the deep ocean, what will happen to the deep ocean biology, ecology? So this type of question again we have to understand totally, then only something can be done. So this will be part of the new science.
Studies.
Recommendations. It's nothing we really have much control over. As Dr. Singh said, I think that there are people who interface with the scientists, and they are policymakers and no policymakers, and that can resonate. The one, you know, as a scientist in general, it's often frustrating when you see a problem and you cannot get anyone to take action on it. So as an international group, we hope that we have a larger leverage than just an individual scientist saying, I think you should do this. So I think that, I don't know that we've authored much about marine policy or anything. We have
There's
a
one
lawyer.
environmental.
We have a lawyer on our SSC we're talking about maritime policy. We've had sessions on marine pollution from shipping, and how, because the ship's plumes put material into the air and then it falls into the ocean, and that can change toxicity or even can increase productivity. It depends on what is in the smoke and stuff. So we've addressed this over the years. We've had discussions and sent the community back with the information. So I think that's our role, more than we can't make any policy ourselves, but we can hope that by informing the community and sending them back to their national wherever they came from, that would be, I think that's all we can hope for. But I think as an international voice, we do have a larger voice than the frustration of a single scientist.
And actually, example of that is very successful success story I can tell you. You know, the 70th lead concentration in the ocean and atmosphere and everywhere, it has increased significantly. And actually it has gone up to that level in the waters and everywhere, that people are correlating the crime in the country, that crime has increased because of lead, because it is neurotoxic. And that, because of scientists, they found out that concentration is high, and from here it is coming. So in the beginning people are not able to believe, but it was coming from leaded gasoline, and entire world now has banned the leaded gasoline, and concentration has gone to the background level. So this type of study really has huge impact, and people listen to that. So it means similarly now, like we are talking coal burning. So coal burning is putting a lot of trace metals and many toxic elements. So again, people from SOLAS or any other people are working on that. And once everything is proven that beyond doubt, government takes care.